Hi, welcome to Sachin Study Tech. Today topic is 0-1 knapsack problem by using backtracking approach. So this is one of the applications of backtracking. So you can use the backtracking approach. You can solve this 0-1 knapsack problem. 0-1 knapsack problem is the objects are not divisible. That means washing machine, fridge, and for example computer. So you cannot take the part of that object. So either you can consider that object completely or you can ignore that object. If you can take that object, that is xa values either 0 or 1, it cannot take any fractions. Either xa value is 0 or 1. That means 0 means you cannot consider that object, 1 means you can consider that object. Here the knapsack means it is a bag. Knapsack means it is a bag. So what are the objects is there, you can carry that weight of that object, then you can get that profit. So here it is, in dynamic programming approach you can solve this problem. In fractional knapsack problem also you can solve. In greedy method also you can solve the fractional knapsack problem. So that is the maximization problem. In dynamic programming approach also you can solve 0-1 knapsack problem. Now we can solve this 0-1 knapsack problem by using backtracking approach. Now we can see, consider the problem having weights and profits. So these are the weights 3, 4, 6, 5 and the profits are 2, 3, 1, 4. So here it is x1 is, here it is x2, here it is x3, here it is x4. 4 objects is there and 4 objects weights are given, and what are the objects here stored, that weight you can consider in that bag, you can store that weight into that bag, then you can get that profit. So how many ways to solve this problem, what are the solutions are existed, how many solutions are existed, you can find out all possible solutions by using backtracking. Now we can see, here it is W and here it is P. So initially I am not considered any weight, and then you cannot get any profit. So here it is, the bag capacity is 8. So here for example, what is the constraint? Here the maximum is, it is optimization problem. For example, here it is pi into xa, that is the objective. Here the constraint is wi into xa, that less than or equal to, here it is, for example I am considering it is a m equal to, for example in this case 8. So this is a constraint and condition. Now we can check, here it is x1 is, so here it is left side is included. Here already in subset, sum of subset problem also you can discuss. Here it is left side it is included, right side it is not included that particular object. Now you can see it is x1 is equal to 1, that means you can consider that weight. So you can consider that weight, it is 0 plus 3, that is 3. If you can consider this weight, you can get the properties 2. So you can get the properties 2. Now we can expand. So here the backtracking follows DFS. So here x2 is equal to 1, that means you can consider the second weight, that is 4. 4 plus 3, that is 7. Here the profit of the second object is 3. So 3 plus 2, that is 5. So here it is 7 less than or equal to 8. This is the constraint. So that is the bounding function. It is a constraint. So it is, condition is true. Then x3 is equal to 1. That means third object is included. Third object weight is 6. 6 plus 7, that is 13. So here the profit is, if you can consider the third object, the profit is 1. So 5 plus 1, that is 6. So here you can see 13 less than or equal to 8. Okay. So you can kill this node. It cannot satisfy that condition, bounding function. You can kill this node. So now here it is x3 is not included. Then so you can include x1 and x2. Now 3, 4, that is 7. That's why you can take directly, here it is 7, and you can get the properties 5. Now we can see, here it is x4 is included, x4 is not included. So if x4 is included, that weight of the x4 is 5. So 5 plus 7, that is 12. So you can include x4. So can get the properties 4 plus 5 that is 9. So here also 12, 12 less than or equal to 8. So you can kill this node. So you can see here it is x4 is not included. That means x1 is included, x2 is included, x3 is not included. That you can add 3, 4, 7. So that's why you can take directly here it is 7. So you can get the properties 5. So this is the one solution. This is the one solution. Like that, here there is no other object. Backtrack and backtrack. Here also backtrack. Now you can see x2 is not included. X2 is not included. Here it is x2 is not included. That means 4 is not included. That's why x is included only 3. Weight is 3. You can store this weight into back and can get the properties 2. Now you can see x3 is included, x3 is not included. Now if x3 is included, so what is the x3 weight? 6 plus 3 that is 9. If we can include the third weight, then you can get the properties 1. So 2 plus 1 that is 3. So here it is 9 less than or equal to 10, 9 less than or equal to 8. The condition is fail, so it is not provide the solution. You can kill this node. If we can x3 is not included, that means so only 3, that is x1 is included, x2 is not included, that is only 3. You can get the properties 2. So you can expand this. x4 is included, x4 is not included. If x4 is included, the weight of the x4 is 5. 5 plus 3 is 8. Here if we can include the x4 5, so you can get the profit is 4. So 4 plus 2 that is 6. This is the another solution. Now we can see x4 is not included. That means what are the values is there? So that is weight is 3 and profit is 2. So this is also another solution. Then there is no other object. Backtrack. Here there is no object. Backtrack. Here also backtrack. Now you can see here also x1 is not included, and right side it is not included. That's why it is not included means what are the values is there in previous. Here it is 0. If you cannot consider any weight, you cannot get any profit is also 0. Now you can see x2 is included, x2 is not included. So if x2 is included, so x2 weight is 4. 0 plus 4 is 4. So profit, so x2 is included, you can get this profit, that is 3. 0 plus 3 is 3. Now it is x3 is included, x3 is not included. If x3 is included, you can so weight of the x3 is 6. 6 plus 4 that is 10. If x3 is included, then you can get the properties 1. So 1 plus 3 that is 4. But here it is 10 less than or equal to 8. So condition fail, bounding function fail, then you can kill this node. So if x3 is not included, then means what is the value is there in previous, that is x1 is not included, x2 is included, that is only 4, and you can get the properties 3. Now we can see x4 is included, x4 is not included. If x4 is included, that means x4 value is 5. So 5 plus 4 that is 9. Here it is, if you can include that 50 weight, you can get this profit. So 3 plus 4 that is 7. But 9 less than or equal to 8, the condition is fail. So you can kill this node. x4 is not included, that means it is 4, and you can get the properties 3. So this is another solution. So there is no other object. Backtrack. Here also backtrack. Here also you can see x2 is not included, x2 is not included. Now x2 is not included, that is x1 is not included, x2 is not included, that you cannot get any weight, then you cannot get any profit. If you cannot store any weight in that bag, then you cannot get any profit. Now you can see here it is x3 is 1, x3 is 0. That means third object is included. If third object is included, the weight is 6, and you can get the profit. The profit is 1. So here it is x4 is included. If x4 is included, that means x4, the cost weight of the x4 object is 5. 5 plus 6 that is 11. it is 11. Here if you can include that x4, so you can get the properties 4, that is 1 plus 4, that is 5. But here 11 less than or equal to 8, condition is fail, you can kill this node. So here it is x4 is not included, x4 is not included, then it is 6 and 1. So this is the another solution. Now we can see here it is x3 is not included, x3 is not included, then x1 is not included, x2 is not included, x3 is also not included, then you cannot carry any weight, you cannot get any profit. So here it is x4 is included and x4 is not included. You can see x4 is included, that means the weight of the x4 is 5, this is 5, here you can get the properties 4, and this is 5 and 4. So if you not, this is the another solution. And also here you can see if you cannot included, here also not included. So how many number of solutions is existed, here you can see in that out of all solutions you can get which is the maximum profit, here you can see. So this is the maximum profit you can get, the weight is 8, so the profit is 6. So here it is a maximum 8, the back capacity is 8, you can consider these are the solutions. Like here it is, for example, how many solutions are, how many nodes are there here. For example, in this 4 object, so all are not included, that is x4, x3, x2 and x1. Here x3, here it is x4, so all are not included. For example, first one is included and our second one is included, or this these two x2 and x1 is included. Like that here it is 1 1 1 1. So this is the number of here the number of nodes is existed, that is here it is 2 power 4, that is 16 nodes. So you can see here it is, but out of this only these are the solutions, this is the so which are the solutions are satisfied the condition is called here, these are the solutions. Out of these solutions, those this is the maximized, so you can get the maximum profit. So thank you for watching this video. So here also you can see what is the 0-1 knapsack problem. Here what is the not time complexity and space complexity also are discussed in 0-1 knapsack problem. Here you can see what is the time complexity of this 0 knapsack problem. Here it is so same as in dynamic programming approach, but here it can follow the how many number of paths is existed, solutions is existed, that is 2 power 4, that is the here it is 2 power n, that is this is the time complexity is 2 power n. Thank you for watching this video.